Today we're going to talk primarily about sourcing and managing geospatial data in ArcGIS Pro and do at least a little bit of analysis. We'll see how far we're actually able to go in our 2 hours here this morning. In terms of my plan, after a brief introduction, I want to talk and practice looking for authoritative spatial data, give you some ideas on where you can go to find data sets that might be important. I'll introduce a task, an analysis task here today, and we'll actually together at least download a couple of data sets from these authoritative places. Otherwise, we'll rely on the data that I've provided for the workshop here today. Once we've acquired all the data that we need for our task, we'll do some data pre-processing analysis and then some brief interpretation and sharing of our results. So something I showed, I think it was in our last workshop, kind of the different dimensions of learning about GIS. Because it's certainly not something that is just focused around software, although that is an important part. Here today, we're going to focus a bit less on the software, I should say, and more on data and some methods. But the methods will be oriented more towards the acquisition and management and pre-processing of data inside the GIS to position ourselves well to do a more kind of robust quantitative analysis that leads us closer to a solution for the task that I'll present here today. Today's workshop is, well, I know this is a really busy slide, but I think it does a pretty decent job of illustrating the complete suite of software applications, GIS software applications that Esri gives us, well, not gives us, allows us to borrow as part of our site license agreement. Today we're going to be working entirely in ArcGIS Pro, the desktop GIS software. Our fourth workshop, which I can't remember the date, I think it's like November 3rd, early November, we'll be working more with Portal, so web-based, cloud-based GIS. And to get us a bit oriented here to the process that we're going to follow here today, and on this slide, I really am focusing on the middle part, the colorful arrows that kind of outlines here the data science process. This is terminology. I've been teaching GIS for a long time, and I've kind of done a better job recently of incorporating kind of more modern terms like data science into GIS classes, because that's exactly what a GIS class is. We've just never kind of touted that as much before. But we're going to have a question or a task that I'll lay out here for us here in a moment, and then we'll go through the classic data science steps. Acquiring the data, cleaning or pre-processing those data sets to get it ready for our analysis. We're going to skip the exploratory piece and then get into a little bit into analysis and modeling and then interpreting and sharing our results, okay? So with that brief overview, the other thing I wanted to highlight here before we went any further is one key enhancement of the ArcGIS Pro software compared to the older Arc Desktop or ArcMap program, which, as we learned on our first workshop here this semester, if you are using that ArcGIS 10.8.2 software, great software package, nothing wrong with it, but it's now basically 25 years old and is being officially retired by Esri in the spring. So now's a great time to make that transition from the older software to the newer ArcGIS Pro. And we talked about in that first workshop some of the key enhancements that ArcGIS Pro gives us as researchers or as outreach specialists. And the one enhancement I want to go back and emphasize here is that ArcGIS Pro, the way it is designed, is it works with projects. And what that means is a single ArcGIS Pro project. And I've shared with you an ArcGIS Pro project. That's what's available at that bit.ly link, that source, analyze, manage, and analyze folder. Is nice because in that one folder, we can have access to all the data that we need for a given project and create as many two-dimensional or three-dimensional maps to support our work. The older ArcMap software was map-based, so you could produce one map. And if you had a complicated, not even a complicated project, I should say, it might be very realistic that you could have a dozen or more map documents for a single project. But with ArcGIS Pro, it is based around a project. There's no real limitation to the number of maps you can have in that project or connections to a variety of data sets. Very, very important. And we'll see this when you open up today's project. You'll see it. I've got a little screen capture here of the catalog pane for ArcGIS Pro. That is a standard design setup structure for an ArcGIS Pro project. You see major categories like maps and toolboxes and databases. We can add to that. We can have not just one map that you get when you open up or create a default project. You can have as many, again, 2D or 3D maps as you'd like. You can have custom toolboxes for your project where you're storing model or script-based tools. You'll always have at least one database. When you create a project in ArcGIS Pro, whatever you name that project, you'll have one database that is part of it. It has the .gdb suffix, so that's known as a file geodatabase, in contrast to a true enterprise scale database that might be available to us, say, through Microsoft SQL Server, Oracle, things like that. You'll always have at least that one. And then there's layout styles and some other things. If I go to today's project, this is what that looks like. And I've got my catalog pane active and anchored on the right-hand side of my screen. And today I just have one map, and it's called the Very Creative Map. Okay? You can name your maps whatever you would like. Today, since we just had one map, I just left it at the default map. You can see that in this project, there are actually two toolboxes. There's one, what I call the default toolbox, which if you expand that, doesn't have anything in it. That toolbox is automatically created, sort of like that default file geodatabase when you create a project. And it could be a great repository for the custom tools that you might build to support your work in this project. Instead of adding tools to a toolbox, the default toolbox, I've added to this project a second toolbox, which you can expand, and there are 5 different tools inside of that. Number 1, watershed delineation, to number 5, tabulate, LULC, land use, land cover, and soil areas. These are all, we'll touch on this at the very end of the workshop, these are all custom model builder models that were created and then published as tools that any of us can operate just like any system toolbox in Arc. Okay. So again, I can have toolboxes that I've created for a variety of projects, and if I want to bring one or more of those into this project, all I have to do is add that toolbox that I've created to this project. More importantly, perhaps, is our data. And I tend to do most of my work in a geodatabase environment. You will rarely see me, for example, use the ubiquitous shapefile format for vector data, points, lines, and polygons. So we've got 2 geodatabases that are part of our project. The default one that's created when the project's initiated, and that's always called whatever you've named the project. Here it's source, manage, and analyze. And I've added a second file geodatabase called Wildcat Creek Data. And if you expand that, you'll see that there are several data sets inside. We've got 1, 2, 3, 4, 5 vector feature classes at the bottom of that list, and another 5 raster data sets that are all inside of that geodatabase. So again, if you've got a geodatabase that you've populated with really good data for previous projects, it's very easy to add that source to this project. In this case, Wildcat Creek, that geodatabase is actually physically located inside the Source, Manage, Analyze project folder. But that does not have to be the case. You can any data resource that you have the ability to connect to, you can add to this project without it being part of the project. Does that make sense? So if I've got a completely different folder or a network drive or an Amazon S3 bucket that contains a bunch of data, I can simply add that source to this project. And when I save the project, that connection to the data is maintained. Okay. And where things like that might come more into play is under the folders section. So if you expand that, you'll see that right now, again, by default, we have a single connection to a folder, to our project folder, Source, Manage, and Analyze, and all the things that were put in that project folder. If I wanted to connect to another folder, right, a folder source of data, maybe that contains shapefiles, all I have to do is right-click on folders and add a folder connection, right, and then navigate to where that's at, and then save it, and it's part of my project. Okay. This, if you've not worked in the older ArcGIS desktop software, the revelation of an ArcGIS Pro project probably isn't as exciting, but this is incredibly helpful as a researcher, right? I can have a complete, say, dissertation project, and I'm managing it through a single environment here in ArcGIS Pro. Okay. Does anybody have any questions about that? That's the one kind of software thing I wanted to highlight here today is projects. Again, if you are working at least partially in a server GIS type of system, you can connect to those online resources. They become something that's available here. If you are, again, I mentioned Amazon S3 data buckets. If that's where you've got a bunch of data stored, you can create connections to that. SQL Server enterprise databases, file folders, whatever that location is, can now be part of your projects, which is a great way to save, kind of be, not save, but be efficient with your data. You don't have to have 5 copies of data sets, one residing in each one of your projects. Say you've got 5 projects. You can just start building as a researcher or an extension specialist data archives on your computer or on a server machine and tap into them for all of your different projects, right? Without having to duplicate data resources. But anyway, my original point here, any questions about projects? So if I go back real quick here to databases and Wildcat Creek, when I save this project and before I posted it in that shared OneDrive folder or on the W drive here in the lab, I designed my map. So I've got a bunch of data from that Wildcat Creek geodatabases participating in the map. You can see that in the content pane. We'll be using a lot of this in our analysis phase today. We'll also be recreating a couple of these feature classes and raster data sets to go through the finding, downloading, and pre-processing of those things. Not everyone, otherwise we'd be here for quite a while just pre-processing data. Unfortunately, that's often the majority of your work is pre-processing the data to get it into a form that's most suitable for the analysis that you want to perform. Okay? Good. Well, let's continue on then I want to talk a bit about authoritative spatial data. So first, why? Why do we place so much importance on authoritative spatial data? Well, there's 4 things I present right here. Accuracy and reliability, right? We want to be using data in our projects that are produced by recognized entities, whether that's a federal, state, or local organization, or if you're producing data yourself, that's probably a more challenging process than you give it in terms of documenting the data that you're producing. Okay? So as scientists, we want to make sure that anything that we're doing in data science, to include GIS, is as sound and reproducible as possible, and using these authoritative data sets produced by recognized agencies goes a long way in helping us achieve those goals. In terms of consistency, depending on the data product that you're looking for, that responsible agency has actually invested a lot of time and effort in establishing the most appropriate methods for creating and documenting and attributing that data. So again, that allows us to, for those that choose to use authoritative data, allows for more reasonable comparisons across different study areas or different projects conducted by different people. Credibility is also an important feature of authoritative data. Using digital elevation data produced by the U.S. Geological Survey, or land use land cover data, again produced maybe by the Multi-Resolution Land Characteristics Consortium. Those key, globally recognized spatial data sets, using those helps give people confidence that the work that you've done and you are presenting is accurate and appropriate. Okay. And then lastly, efficiency and risk reduction. Why recreate the wheel, create a brand new data set when a recognized agency has already done that work for you? Take advantage of the data that exists. That gives you a better chance not only of achieving these other 3 goals of using authoritative data, it also minimizes the risk of using outdated data or data that other people would have a hard time reproducing to do the same analysis that you've done, to replicate that work, or to carry those methods over to a different study area. So using authoritative data, critical, right, in any data science endeavor. Really using authoritative spatial data, not to beat a dead horse here, is the foundation of any reliable or credible GIS-based analysis. And in general, there are 3, one of those numbers, 3 places that we can look to find such data sets. Federal data portals, and we'll take a look at a couple of those here in a moment, are a great place. States and local GIS clearinghouses are another option. That varies a little bit depending on the state that you're in, because different states do things differently and invest different amount of resources into managing state and local, for that matter, GIS data sets. You can also look to universities or even ESRI, the Environmental Systems Research Institute, as great sources for authoritative data. So I've selected just a couple to share here today, and if you've got questions about where you might go to find authoritative data, by all means, please ask. I don't necessarily know where you can get every possible data set, but I might be able to point you in the right direction. In terms of federal GIS data portals, there are 2 sites that I strongly recommend you become familiar with. That's the National Map Viewer And if you want to download data from the national map, there's a separate application called the National Map Downloader. And I'll pull that up here real quick. If you've opened up the PowerPoint, that's part of our project. You can just click on those links and access the websites that I'm looking at. This is the U.S. National Map Data Viewer. So if you're just interested in looking at data and seeing maybe what data is available through this federal GIS data portal, this is a good place to go. More importantly, and what I actually personally use as both the viewer and the downloading application, is its companion app, the National Map Downloader. And it looks a little bit different because a lot of this screen real estate is devoted to your ability to interact with the map, to specify what you want to download and for what geographic area. So we're actually, if you could, I'd like you to open up this website as well, because we'll go ahead and start downloading one data set here that we'll use in our analysis. The URL, you can actually just Google TNM download or the National Map download, and it will take you to this site. So the national map, kind of its origin or its purpose is to serve up data sets produced by a variety of spatial agencies in one convenient location. And a lot of these data sets actually, they may not have even actually been produced by a federal agency, but any data produced by states then gets reported up through the spatial data infrastructure system in the country, gets ingested by federal agencies, combined to produce national data. It's called the national quilt of data. If you're a quilter, that might make sense. With the TNM download application, I actually want to download some digital elevation data. Is everybody familiar with what a DEM is? It's a raster representation of elevation above mean sea level. And to do that, I'm going to be looking on the left-hand side of the screen here, and I'm going to scroll down through these different data categories and choose elevation products. Some of you may have heard of a program in the past called the National Elevation Dataset, or the NED. That has been superseded by a new USGS initiative called the 3D Elevation Program, or 3DEP. And here within the different elevation products, I actually want to find the entry here that says 1/3 arcsecond DEM. And already we're down in the weeds in terms of spatial reference systems. Anybody know what a 1/3 arcsecond is in terms of meters? I always forget and often have to look up. It's a 10-meter DEM. And one of the reason why USGS packages this data in terms of arcseconds as the representation of linear distances is this digital elevation data is going to be unprojected geographic coordinates. So if you're familiar with the oblate ellipsoidal shape of the Earth, the size of a pixel near the equator is going to be a little bit bigger than it is at the pole. So they just, rather than say it's a 10-meter DEM, well, it is, but not everywhere, depending on where you extract the data. So this 1/3 arcsecond is a 10-meter DEM, and 10-meter DEMs is the national standard for digital elevation models. You might see a 1/9 arcsecond DEM right below it. That is a 1-meter DEM, probably produced using LiDAR data acquired by local governments or state governments, and again being contributed to the national map. With 1/3 arcsecond selected, if you want to show, or click the link for show, it will then give you an indication where in the country that data set is available. So again, I mentioned before, 1/3 arcsecond DEM is the national standard, so we've got it available everywhere, at least in the continental United States. If I were to go back to the 1/9 arcsecond and show its availability, it's a little bit less. See the darker orange areas. So we don't have national coverage at the 1 meter spatial resolution for elevation data. Okay. So I'll hide that. So now that we've selected, I've misselected. I'm going to go back and select the 1/3 arcsecond DEM as my target here. And scrolling back up to the top of our downloading tools. Actually, I'm going to go to the map, I think, and kind of zoom in to the Manhattan area. Our study area, I haven't revealed our task for today, but our study area is going to be the Wildcat Creek watershed, which exists kind of in between Manhattan and Fort Riley. So I've zoomed into that approximate area. And
can you just type in and search for Manhattan?
You can, well, no, you can. There is a search bar over here, which you can. Yeah, I guess I don't do that. So I was just like, well, yeah, I guess you can. That might work really well if you're like super unfamiliar, right, with an area. So searching by place, manually zooming in and zooming out to the spatial extent of your study area. If you've got a shapefile, you can actually use upload a shapefile to the downloading application to define your study area, or you can draw a polygon on the map and say, this is my study area. Okay. So I'm just zoomed in to an area that I know contains my area of interest, and I'm going to define that here, area of interest, as my map extent. So I just click on that. So now the application knows I'm looking for 1/3 arcsecond DEMs in this geographic area. Yeah.
Can we drop a pin so that every time we open it up, it takes you exactly to that spot?
It wouldn't, that pin or that point would not be retained across multiple sessions. But you could use a single point if you wanted to add that to download multiple data layers in a single session. Same thing with the map extent, right? I can just settle my map extent here or draw a polygon, a box around that area, and use that to download multiple data sets here from the application. So let me go back to map extent. And once I've done that, just double check that I've selected the right data layer. I can search for products. What 1/3 arcsecond data set is available there? And that gave me an error. I didn't like that. Okay, yeah, because I didn't hit extend. So if you're successful, regardless of the technique that you're using to define your study area's spatial extent, when you click on that search products, you'll get all the files, in this case, just those 1/3 arcsecond 10 meter DEMs that were within that area. And surprisingly, maybe to some, there are 1, 2, 3, 4 in that window. That's kind of a rule in GIS, regardless of where your study area is at, you almost always have to download multiple files. Your data is never conveniently in one file. But actually, in this case, that's false. If I zoom back out a little bit, as you move your mouse over those available data sets, its footprint will be highlighted in the map. So this first DEM was in my map extent, but actually I'm going to ignore that one. That is not the Wildcat Creek, and I just happen to know this, right, doesn't fall anywhere within that DEM. If I go down to the second one, again, I captured just a little corner of that larger geographic area for that DEM, so it's being returned to me here as a product. This is the one I actually want. Okay. Its name is North N40 W097. So it's kind of giving you a geographic coordinate tile. and then the date that that DEM was last produced or modified by USGS, which was the summer of 2023, June 13th. Okay. We want that one. North 40, West 97. If we wanted multiple ones, we could download all of those right here. But since this is the one that we want, all you have to do then is click the download link button that's part of that product description. And the download starts. Now, if I go back real quick, I probably should have pointed this out before. I had accepted the default file format for this file to be a GeoTIFF. And that's fine. A GeoTIFF is a TIFF file, which is a perfectly valid raster format. The geo means that TIFF file understands its geography. It's a geo-referenced TIFF file versus a TIFF file that your phone may capture when you take a picture. So this is a pretty big chunk of real estate. So it takes a bit here to actually download, and I'm looking here in my browser. And now, if I go to my download folder where this TIFF exists, and pull it back over, there it is, right? Just a single file with a .tif suffix is that large geographic area, 1/3 arcsecond or 10-meter DEM. Now, what to do with this file? Okay. What I do is I want to get that TIFF moved out of my data downloads folder on my computer, which for me is kind of a junk folder. It's a temporary storage place for things. And I want to move this either into a more permanent repository on my computer or a network drive. Here, let's just copy it into our ArcGIS Pro project, the source, analyze, manage, and analyze folder. So I'll right-click, do a cut, and then navigate to where I put my project file, which is on the desktop, and I can store it anywhere in this. It's just a file, right? So I'm just going to paste it right into my project. There it is. Sometimes what I like to do in projects like this, again, I'm in the source, manage, and analyze project, is sometimes I'll create a new folder in that project called data downloads, right? And then put everything that I've downloaded into there. Doesn't really matter. It's how you choose to organize your spatial data. But now that I have that, I can come back to ArcGIS Pro. And remember where I said we can look at content in a folder? So I'm going to expand my project folder, source, manage, and analyze. As I look at the content there, I don't yet see that TIFF file. To see it, I need to tell ArcGIS Pro to refresh the view. So I'll right-click on source, manage, and analyze, refresh, and then there's that TIFF file. Right at the very bottom. Now that I've got access to that TIFF, I'm going to actually, in my map here, I'm going to turn off the data layer that begins with DEM because I've pre-processed this ahead of time. But if I can find the TIFF that I downloaded in my catalog pane, I can highlight it and just add it, right-click, add to current map, or drag and drop it into the contents of my current map. Maybe. Just thinking about it. Oh, sometimes, yeah. Usually when Arc asks you to calculate statistics, say yes. Otherwise, the display will be kind of wonky. Oh, and there I added two, of course, I added two. I'll remove one. And there's that file we just downloaded. So a big chunk of northeastern Kansas was included. That's the smallest tile that you can download from the National Map Downloader. And as you can see, that green outline watershed for Wildcat Creek is fully contained within that digital elevation model. Now, whether you were successful in downloading that file or not, we can proceed with what we want to do today using the DEM that I've provided for us. But I thought that was a good exercise to go through, very typical procedure for grabbing data from the national map. If you've got that data file, we'll use it again here in a moment to do a bit of pre-processing, because we really don't care about the elevation data in that entire file, just a small little part of it. Okay, before I move on, any questions that I can try to answer? Okay, so before we go any farther, let me unveil a bit about our task here today. Why are we downloading the data that we're working with? What are we working our way towards? And I realize this isn't a surface hydrology modeling class, but we're setting up a surface hydrology analysis problem here. So we're going to use GIS to prepare and do at least some initial analysis for Wildcat Creek. And our plan is to use GIS not as our primary analytical platform, but to prepare data that's needed to fulfill the modeling parameters for the NRCS TR55 hydrologic model. Is anybody familiar with TR55? No, natural resource, small watershed hydrology modelers out there? That's okay. That's okay. So part of this process to run the model for Wildcat Creek, which is infamous for flooding periodically if you've lived around town for very long, TR55 will allow us to look at the impact of land cover and soils on the streams, on stream flow, and help decode why Wildcat Creek seems to be flooding more frequently now than it used to in the past. So to do that, we're going to take a look a little bit at that DEM, but more at some contemporary and historical land use, land cover data, as well as soils. So we're going to use that to uncover some information that's needed, again, to parameterize TR55, and hopefully along the way show how we can use GIS to help us estimate runoff, peak stream discharge, time of concentration, and other things that are relevant for surface hydrology. And really what we're attempting to do, what TR55 is going to allow us to do, is recreate this graph on the right, a stream hydrograph. In response to a certain rainfall event, how is that rainfall event going to impact stream flow in Wildcat Creek? Not only in terms of discharge, but when that peak discharge will take place. Okay. And to create that graph, we'll use TR55, which looks like this. And if you look closely here in this parameters screen, you see a variety of different land cover types on the left. And then on the right, those numbers represent the acres for different combinations of land cover that fall on certain soil types, represented here by soil hydrologic group. Now there's a process for figuring that out and to identify what's called a curve number that represents that unique combination of land cover and soil type. We won't get into that too much, but this is what we need the GIS to help us figure out, is what numbers are we going to plug into this model to give us a reasonable result. Okay. What that in the end looks like, I'll pull up TR55 here real quick, is I want, for a 10-year storm, let's say, this is what the stream hydrograph for Wildcat Creek, a pretty reasonable representation of that. So after the peak of a 10-year storm event, about 10 hours later, Wildcat Creek is expected to hit its peak discharge of about 900 cubic feet per second under current conditions, land cover, and soils. Okay. At the end, I'll show what this hydrograph looks like if it were like prehistory times. And we could see the difference in the hydrograph, flooding potential, that's being driven largely by changing land cover within the Wildcat Creek watershed. Okay. But to get that, we need to understand how land use, land cover, and soils are interacting within our study area. So some data that we'll need for that. I've already acquired for us a watershed boundary for Wildcat Creek. I acquired that from the USGS 3D hydrography program, 3D HP. And the link here will take you to that website where you can simply download watershed boundaries at a variety of scale. Everything from the Missouri River Basin to the two small watersheds here that actually comprise Wildcat Creek. These are Huck 12 watersheds. We may also want some administrative boundaries, county boundaries. And we can get those from a couple of different places. We'll go through the process together of downloading the U.S. Census Tiger Line shapefile for county boundaries in the United States. You can also get the exact same data from a state clearinghouse, the Kansas Data Access and Support Center, or from Esri, not a focus of today, the Cloud GIS, but they have the same data set in what they call their Living Atlas project. So let's go ahead, before we go on, let's go ahead and grab county boundaries. And we're going to do this using the Tiger Census, U.S. Census Tiger Line shapefiles. Again, if you've got the PowerPoint open on your screen, you can just click on that link to open the website, or you can simply Google U.S. Census Tiger Line shapefiles. I have that already open somewhere. Find my web browser. Where is my web browser? There it is. There we go. Census Bureau historically has been a very innovative federal organization with regards to spatial data. These Tiger Line shapefiles were highly innovative in the 1980s. And they still retain that name mostly for familiarity's sake. But if you're looking for authoritative boundary information, whether it's state, county, census blocks, census tracts, the Census Bureau products are the place to go. But here I'm going to go ahead, let's see what they have in I'm going to leave it on 2025 here. And I'm going to go to the FTP archive. I guess this is old school, FTP downloads. And on their FTP site, and this is just one of many places within the Census Bureau you can go to obtain this data. I find it actually easier to go to their FTP site. And if you scroll down, you're looking for the folder called County. And just click on County. Here, after you click on counties, you see there's a file here called TL2025uscounty.zip. I'm going to go ahead and select that file, and it should download just like that TIFF file did for us earlier. Now, this is not a raster. If I go to the downloads folder, I mean, that downloaded very quickly. But it is a compressed zip file. So if I right-click here in Windows Explorer and just extract all, which you have to do to access the data, there is the result. So if you've been in a previous workshop, here's your quiz for a Monday. Is that one shapefile or multiple shapefiles? It's one shapefile, which is one reason why when we're working with especially shapefiles, which are great and terrible at the same time, it's best to manage your file-based spatial data resources not in an application like File Explorer, but in your GIS software. And the reason I say that, all of these files comprise one shapefile. So functionally, they are one file. If I remove anything from one of these constituents, I break the shapefile. If I want to share this shapefile with someone, and I only grab the file that has the .shp suffix, the person I'm giving this data to will not be able to use it. So instead, it's always better to come back to your GIS software. I am going to look in my catalog pane, right-click on folders, and I'm going to add a folder connection to my downloads, which is under Sean and downloads. So I want this folder to now be part of my ArcGIS Pro project. And if I expand downloads, and then the new folder that I created that contains that shapefile, there is my shapefile. Okay. And what I can do now, again, I didn't move it anywhere. I just downloaded it, kept it in that same location. I mapped that folder as part of my project. And just like we did with the TIFF, I can right-click on that and add it to my current map. Now, the problem with that, if I right-click on that boundary file and zoom to layer, is it is all U.S. states and territories. Okay. And for this, let's just imagine we only want Kansas. So I've kind of zoomed in to Kansas. And like everything in a GIS, we've got a couple of options for how we can pre-process this data to get just the counties that we want. One might be by selecting map on the main menu, find the select tool, and I could just click on Riley County. If I can navigate to where Riley County is, which is really easy to spot because Riley County is so uniquely shaped, I can just click on it. And I have just selected Riley County. And from all the county boundaries, that one file, I can then right-click, choose Data, and Export Features, and write Riley County out as just one county boundary as a new file. That could be a shapefile, or I could put that into a file geodatabase as a feature class. Kind of depends on what you want to do. Okay. I'm not going to do that. I'm going to show you another option that we have. But that's one. The disadvantage is you're creating a new file. It's a small disadvantage, but it's a disadvantage. Alternatively, and if I clear my selection, we can also use to our advantage what are called definition queries. So I'm going to right-click after adding all the counties, that one file to my contents pane. I'm going to right-click and find properties from the context menu. And here from the list of properties, find and select definition query. And we're going to apply a new SQL query against this large file, large in the sense that it has every single county in it, to pick out either just Kansas counties or just Riley County. And to do that, we have to be familiar with the attribute table of that file, right? How do we want to structure our SQL query? But if I come in and simply say, let's go state FP, that is secret code for state FIPS code. FIPS is Federal Identification Processing System. It's a census term. Every state, every county has a unique number in this FIPS system. So I can use that. And if I say state FP is equal to 20, 20 is the state code for Kansas, and hit apply and OK. Everything that isn't a FIPS code 20 disappears from my map. So that definition query that I've applied to that larger file now functionally behaves as though it's just Kansas counties. Okay. Or I could have gone in and queried for Riley County, Kansas, right, to just grab that one file. So again, a couple of options that you've got to pre-process if that county boundary file is critical for you. A couple of ways to get it. Plus, we got a chance to interact a bit with the Census Bureau website. So Matthew mentioned before, He likes the Census Bureau web interface. Another option, something we didn't get a chance to look at before, but another option, since this is data that's specific to Kansas, is we could take advantage of the state's GIS data repository, which is available at kansasgis.org. This is the State of Kansas Data Access and Support Center, known by and large by the acronym DASC. And relatively recently, they've reorganized their system to be an ArcGIS hub site. So you can just click on that link and search for, potentially download, or connect to as a web service a variety of data sets that are specific to Kansas. So in their GIS data catalog here, I can choose something like boundaries and demographics. I can start seeing all the data sets that are available here. Sometimes what you're looking for is right there, but if I search for county, not CP, CO, and hit enter, there's a web mapping application that shows county boundaries. There's a map here, county. Oh, there's a data set, Tiger 2020 counties. So it's a little bit older. It's not the 2025 data, but the county boundaries in Kansas, when's the last time those have changed? Early 1900s, when Garfield County was merged into what's now Finney County. So the county boundaries don't change very frequently. So I could click on that. I get to see a preview of what that data set looks like. And since this was a data set, I can just click the download button. And I've got a couple of formats here, maybe a shapefile. Okay. Now that would just give me Kansas counties. Okay. So a couple different sources for it's not Kansas produced data. Kansas has just taken the federal data and customized it so it just reflects Kansas. So it's still U.S. Census Bureau data. We just acquired it through a state clearinghouse DASC. Okay. Watershed boundary taken care of. We've grabbed county boundary, which actually was also taken care of as well. We're also going to need potentially, although we won't use it in a tool here today, the elevation data that we acquired earlier. Two more data sets that will be most critical to our analysis is land use and land cover. How many of you have need to ever work with land use, land cover data? It's probably one of the most common data sets that is used across disciplines. We need to know frequently what land use. That's land use or land cover, because the system covers both. Grasslands, urban, land use, land cover. The authoritative place to grab that is the Multi-Resolution Land Characteristics Consortium, which I will go to, maybe. I have too many windows open. Okay. So this is the home for the National Land Cover Database Program, which is a multi-federal agency partnership. And if I want land cover data for the United States, I can choose data from the main menu and downloads. Internet is slow today. And you can see there's a bunch of different things, land cover related data products that I can acquire here. If I choose annual NLCD as my option, that will refine my search down to 344 possibilities. And you can see that now we actually have products for land cover for the continental United States every single year. This is for the entire continental United States. So if you click download, which you are welcome to do, we don't actually need this for today. I've already acquired that data for us. But it would be a large geographic extent that's going to require a bit of pre-processing. Actually, the same pre-processing we're going to do with that DEM that we downloaded earlier. Okay. Land cover, here. Has anybody heard of Cropscape? USDA in National Ag Statistics Surface Cropscape Cropland Data Layer. That's a very popular source of land cover information as well. What many people don't realize is it is built off of the National Land Cover Database, what we're looking at right here. The only difference is USDA has gone in anywhere where there's cultivated cropland in the National Land Cover Database. They're attempting to go in and say what type of crop was grown there that year. Okay. So if I come back, I've done this download and pre-processing already. If I come back to ArcGIS Pro real quick, this is kind of fun. I'm going to turn off my counties and my TIFF file here. I'm going to zoom in to Riley County. And rather than the DEM, I want to turn on the layer called NLCD 2024. So I downloaded from that website the 2024 annual NLCD. I extracted just the area inside of Riley County, and this is what that looks like. Okay, and if I expand the legend, you can see this is a modified Anderson Level 2 classification for land use, land cover. If I come back in here, I want to turn off Wildcat Creek. I'm going to zoom in to part of Manhattan. Okay. All the red that you see is a developed land use type from high intensity to low intensity. High intensity is the darker reds, like the core downtown is represented there. But this is a pretty good estimate of what current land cover conditions are. I also went ahead, and if I turn on NLCD 1985, downloaded the 1985 land cover data set, okay, which is different. So to see that, rather than turn on and turn off, 2024, 85, 2024, 85, I'm going to go up, I'm going to select 1985 from my contents pane. And when I do that, the dynamic menu at the top changes, and I'm going to find and select raster layer. And I'm going to choose the swipe option. And when I do that, I can now move to the right, the 1985, to reveal whatever's turned on underneath it. So what's that area in northwestern, well actually the entire, let me zoom out a bit. There you can see what has land cover done over the last couple of decades, right? You can see how much more red is present, especially in the western part of town, around the Grand Mere development, along the road that I fondly call formerly Scenic Drive, down around the airport and parts of Fort Riley as well. So we've had a tremendous amount of land cover change, mostly towards urbanization in this area, which if I turn on the boundary for Wildcat Creek, also corresponds with key areas inside of our watershed. You had a question or a comment?
So if you were to extract the soil data, would you be able to do that from this file?
Not from this file. We have to download a different data set for the soils. But that's what we're setting up to do.
So if you wanted to see how the pH has changed over time.
Ooh. Maybe with the soils data, the way that the USDA NRCS kind of organizes and processes that, the soil properties don't really change over time.
pH does change.
But this is the same information that you would be getting from an old school book like a soil survey. So it's not necessarily reflecting soil conditions in an agricultural field. It's for this general type of soil, here's an array of attribute values that typically correspond with that. But we are going to attempt to grab some soils data. I'll show you where you can get that, because that's the other piece for our watershed modeling here is some soil type information. Okay, so already we've got a little bit of a clue here as to why flooding in Wildcat Creek has gotten more common over time. We have a lot more urban, impervious, lower infiltration capability types of places within the watershed. Okay. Lastly, last key bit of data that we need is soils. Does anybody work with soils data very much? Yeah. Where's all the natural resource people this week? I picked the wrong topic to demonstrate. So soils. Soils is a hard data set to work with. There is a website that you can go to, the USDA Natural Resources Conservation Service Web Soil Survey, to acquire this data. And this is what this website looks like. If you start the Web Soil Survey, you enter into a web interface that allows you to kind of navigate to where you want the soils data and can download it. Right here at download soils data. There are two basic soil map products that you can acquire in the United States. One is called the Soil Survey Area Geographic. The acronym is SURGO, S-S-U-R-G-O. That is the most detailed soils information that you can acquire. The other is called StatsGo2. It is a generalized soil map of the entire United States, so much coarser resolution, more approximate. Unfortunately, so if I wanted the detailed SURGO data, I can pick Kansas and go through the process here of downloading, which I won't do. I mentioned before, soils data is challenging because NRCS has organized it as a series of geodatabase tables, like hundreds of tables that contain the soil properties that you might be interested in. When you download the data, those tables are not connected to the soil polygons, okay, the general extents of different soil types. So you have to go through a process of table joins, which we've done in past workshops. Find the attribute table that contains the soil properties you want, and then connect them to the polygons. Seems straightforward enough, but depending on the soil property that you want, you may actually have to perform like 5 table joins because of a very detailed database structure. So working with soils requires you to also have access to a database diagram so that you can properly assemble the soils data that you want. I've done that for us. If I go back to ArcGIS Pro again and turn off my NLCD and find the SURGO hydro group for Riley County, I went ahead and assembled this soil property, which is soil hydrologic group, A, B, C, and D. And those letters represent different categories of soil infiltration. I've color-coded these values where red are D soils, which have the lowest infiltration. It's kind of reverse order. As you go from D to A, infiltration ability increases. Right, so if we have a rainfall event, what's going to happen to the water that falls on D types of soils? Well, it's probably going to run off, right? Clay soils. If it's on an A type of soil, it's probably going to infiltrate because it's a real sandy type of soil. What do you notice here with the color scheme for Riley County? It's red, right? Basically, the entire county is soil hydrologic group D, which is the highest runoff capacity soils that there are. You'll also notice, if I zoom in, do you see all the different polygon boundaries in there that have the same soil hydrologic group property, right? All those polygon boundaries are the original Surgo polygon boundaries. When I chose to represent soil hydrologic group, I now have adjacent polygons that have the same value. So to simplify that, what I can do is, instead of working with data that looks like this, I can work with data that looks like this. What happened to all those internal boundaries between polygons that have the same value? I got rid of them through what's called a dissolve operation. And why is that important? Well, if I go back to Riley, and this is all of Riley County, if I open up its attribute table, in Riley County there were, rounded up to the nearest 1,000, 11,000 polygons. Okay? That's a pretty large vector data set. If I do the same thing with my dissolved version, there are 7 polygons. Okay? So that dissolve operation that was not necessitated, but something I would encourage you to think about after you actually map a value that you want, that dissolve operation is going to make any subsequent operations I perform using this soils data layer go a lot faster. Okay. So, I now have all of my key data. Wildcat Creek, as we've seen before, falls entirely inside of Riley County. I have a DEM. I have land cover, both contemporary and historic land cover. And I have the soils information that I need to plug into my TR55 model here. Okay. If I were attempting to do this from scratch, if I came in today with an empty project and needed to download all that data and do my pre-processing, there's probably a good 45 minutes to an hour worth of work just in doing that to get me to this stage where I can start to integrate my spatial data sets to create the result that I need to accomplish my objective. In terms of managing that data, for the most part, I am storing everything inside my ArcGIS Pro project structure. The data is contained in its entirety, despite the things that we've done here, in a single file geodatabase called Wildcat Creek. That's part of my project. If for some reason I need to connect to other data resources, like we did with our downloads, I've seen how I can map those folders and access them right inside my project. Okay. And as soon as I save my project, which I just did, any connection that I made will be retained the next time I start up ArcGIS Pro. And kind of where we are in this data science process is wrapping up our pre-processing. So we spent a lot of time looking at places to acquire data. We did go out and grab a digital elevation model and county boundaries, but there are some other things that really need to be done, some of which we'll do here in a moment. Others, we're just going to take the data that I've provided for you. So we saw already how with the counties that we could use a definition query to narrow down the spatial units that we want to work with, or we can just do it old school, manually select Riley County and export it as a new feature class. With the digital elevation model as well as our land cover data, the task that remains is to extract the area that we really need. And we're going to play with the DEM for this purpose and highlight the very useful tool called Extract by Mask. Moving back to ArcGIS Pro, I pulled up the DEM, the complete tile of that DEM that we downloaded earlier. Now, it's hard to see, but there's also Riley counties right there. I'll change the color so it's easy to read or to see. But really what we need, the geographic area that's going to be part of our analysis, isn't the current spatial extent or Riley County. It's really just the area that's inside of the Wildcat Creek boundary. That's the data that we need, not only for elevation, but also land cover and for soils. And while this step technically may not be necessary, one of the things that I like to do is to make my data files that I'm going to be processing later as small and as efficient as possible to reduce computation time, right? Performing a raster calculation on a file that has a very large spatial extent will take significantly longer than performing that calculation for a smaller spatial extent. And the same rule really applies with vector data as well. So yes, I have all the elevation data I need, but really I just need the pixels, the cell values inside of the watershed. So when you encounter situations like that in your own work and you're working with raster data, really the premier tool to use is called Extract by Mask. So I'm going to find Analysis on the main menu and Geoprocessing. This is the old Arc toolbox. And if I choose Toolboxes in the Geoprocessing pane, which is anchored on the right-hand side of my screen, you can see that there are many toolboxes here. Okay. These are all called system tools. These are geoprocessing tools that the good people at Esri have programmed for us that we can simply use right out of the box. If you know where the specific tool that you want to use is located in this structure, you can navigate to it. Or, like I like to do, I can simply search for that tool. That, though, requires you to know the approximate name of the tool. So I'm going to type in the find extract and by, sort of. And even though I misspelled that, it's still pulled up as the very first result, the tool that I want to apply here, Extract by Mask. So I'm going to go ahead and click on that, make this window just a little bit bigger. And now I'm entering into a standard tool dialog. There's over 1,000 system tools in ArcGIS Pro, some of which are more commonly used than others. But this style of geoprocessing this is kind of the entry level, I guess, geoprocessing is using individual tools and completing the information that's required in the dialog, which consists of required and sometimes some optional parameters. Here in a minute, we're going to transition to using models as our geoprocessing platform. And if you are interested at some point, the other way that we can do geoprocessing in ArcGIS Pro is through Python, right? So we can write scripts that automate our workflows as well. Which one's better? They all get you to the same endpoint. Sometimes certain techniques or approaches are more efficient than others, but there's not really a strong reason to prefer Python over tool dialogues unless you're really designing workflows or wanting to incorporate some techniques using Python that otherwise wouldn't be available in the software. So back to ArcGIS Pro. My input raster here is going to be that TIFF file that I downloaded, the elevation. So I just pick it as my input raster. The feature mask data, that is prompting me for a boundary for the area that I want to keep. It's a cookie cutter operation. So my feature mask data, I don't have a raster representing that, but instead I want to grab the polygons represented in WBD HU12 _ Wildcat Creek. That's the area that we're looking at here in green on the map. So I'm going to use that as a cookie cutter to cut out the elevation values just within that boundary. To make that work a little bit better, I'm going to go, actually, that's all I'm going to do. Okay, and just hit run. So it's producing a file called extract USGS1. I probably should have given that a more useful name. But there's my result. Where did that file go? Obviously, it's been created. It's called extract. By default, the location where any tool outputs are going is the default geodatabase of your project. You can change that, but by default, it's going to be back here in databases under Source, Manage, Analyze. There you see that raster data set that was just created, okay, which is kind of nice. We've got a built-in workspace, essentially, to store all of our outputs. That's part of our project. Same thing I would do. We won't do it since we didn't download the data. But I have in the Wildcat Creek geodatabase, if you're interested, a file here called Annual NLCD for 2024. If I add that to my current map and zoom to its extent, I cropped out all of Kansas. Clearly, we don't need all of that data. We just need land cover inside of our Wildcat Creek boundary. So to get that, I followed the same procedure. I extracted by mask, and in doing so, that left me, well, with Riley County. I would want to go back in and do this one more time for the Wildcat Creek boundary, which I probably should do, shouldn't I? Yes. So let me go ahead and do that real quick. So I'll take my land cover by my watershed boundary. Turn that off while it's calculating. Where did it go? I think I inadvertently deleted it, sorry. Add that back to my map, and there's the result. Okay. 2024 land cover inside of my area of interest. Coming back real quickly to my soils, we talked before, if you were successfully able to download the Surgo data from the Web Soil Survey and then go through that dissolve operation to reduce the number of polygons in our output there. Again, I have need to take all of Riley County and narrow it down to just the area inside of my watershed. But I've transitioned here from using a raster data set, my DEM, and my land cover. Now I've got vector input, polygons. So the tool that I use to do this cookie cutter operation changes. Instead of extract by mask, I'm going to find from geoprocessing the good old clip tool. I can't spell today. Clip. I'm going to take my dissolved soils, clip it by my watershed boundary to get my output. All of these outputs are going into my default geodatabase. So now I got to turn off. There's my soils. So again, continuing this pre-processing operation, but using a couple of very common geoprocessing tools gives me not only soils for Wildcat Creek, now I can't find it, but also my land cover. Okay. Now that I've got that, I'm almost ready to start moving into the hydrologic modeling piece. But there's some interesting information we may want to extract from these two data products. And to do that, this might be considered kind of some analysis here. One of the things that we might want to do is calculate how many total acres of each different land use land cover type exists within the watershed. We'll do that just for 2024, but we could do it if we wanted for both of the dates, right? If you wanted to do a historical comparison. To do this though, there isn't a single tool in our toolbox or the geoprocessing pane that does it for us. So instead, we'll real quickly take a look at how we can do this using a model. A model in ArcGIS Pro. I'm going to expand toolboxes, and in that custom toolbox called Watershed Tools, I want to find number 3, Summarize Land Use and Land Cover. And for you, you can just double click on that model to run it just like any other geoprocessing tool. Double click, and it looks like a system toolbox.
So this is a tool that you set up for us?
It's a model as a tool that I've set up. So we would want to execute it just as is. We want to take the 2024 NLCD data, our land cover data, our input watershed polygon is Wildcat Creek, and then you can leave the output file name exactly as I have it. So to you, it looks like a tool. In reality, if I show you, it's actually a model that has 2 geoprocessing tools. So a simple model that takes my raw data and allows me to calculate via this tool, calculate field, how many acres, and those units are important, how many acres of each land use land cover type exist within Wildcat Creek. Let me show you real quick what that data currently looks like. There's the map of land cover, but if I open up its attribute table, this is all I see. It's kind of strange. I have a value. Each number represents a discrete land cover type that corresponds to that last column, the NLCD land cover class. So value 11 in this framework is always open water. But notice there's nothing in there that tells me how many, the geographic area of that land cover type. Sort of, I kind of lied there. We have red, green, blue, and opacity. That's actually being used as a color map to symbolize our land cover types. The only thing that comes close to giving us an indication of the area of each one of those types is the field count. And that's something you see in every raster data set. There are 343 cells in this Wildcat Creek watershed that are open water. There are 7,514 developed open space. Okay? But those are cells, not necessarily areas. But we can calculate the area that those cells occupy if you know a little bit about the data. The NLCD is a 30-meter resolution product. Every cell is 900 square meters. 900 square meters times the count gives you an area in square meters, and then we need to do the transformation from square meters to acres. That's what my model does. Surprisingly, that takes 2 steps to do. So I've automated that in a model builder model that I've published as a tool, so I can just run that tool to get the desired output. Takes a second. This produces an output table that's in my Scratch or geodatabase, which I need to refresh to see. Oh no, it is. It's Watershed NLCD 2024. This one right here. And now if I open up its attribute table, I have additional information. I have a final attribute field here called acres. Okay. I could do the same thing with my soils data, right? Calculate what proportion by acre each soil hydrologic group represent. Here, if I wanted to do kind of a time series analysis, which I've done, we won't have time to do that today. Here's a quick chart created in ArcGIS Pro that shows the acreage of each land cover type in 1985, that's the light blue bars, versus 2024. Right? And there's been a surprising amount of change, particularly in cultivated crops, grassland, and those developed land cover categories. Okay. Generally moving towards less pervious surfaces, right? Which promotes runoff, hence some of our flooding challenges in Wildcat Creek. How did I create that? I just calculated the number of acres at 2 different time periods. Again, similar, we could come up with the same calculation for soils. Okay? But ultimately what we need to accomplish here is for parameterizing our water, our hydrology model, is the number of acres, not just of land cover, and not just of, not soils, or our soil hydrologic groups. We need to understand where different combinations of land cover and soils exist. Where do we see grasslands on A soils versus D soils, for example? That's the information we need to plug into our model. To help with that, I've gone ahead, actually we're going to need to run real quick here, tool number 4 as well. Summarize soil properties. So you can grab either the dissolved or the undissolved version of our soils. Wildcat Creek is our watershed polygon. It's going to produce a new soils output that has the acres associated with it as well. There we go. And just to show, open up that attribute table. There's my acreage. And as per norm, especially in the Flint Hills, D type of soils dominate. So we know soils, we know land cover. Let's then cross-tabulate how many acres of unique land cover and soil property combinations exist. And to do that, I've got one final model that we can run. Okay, a little bit more complicated than the previous ones, but we can just execute this as is. This is going to produce a table output, not a map, just a table. And that table, rather than show it in the GIS, looks like this, at least part of it. So it's a cross-tabulation. Again, inside of my map interface, inside of ArcGIS Pro, I can see every unique combination of land cover type and soils. So value 22 is developed low intensity, value 41 is deciduous forest. So how many, and this is square meters, how many square meters of deciduous forest on C soils exist in Wildcat Creek? I can find that right here in this table. This is the basic information I then need to have translating from the GIS into my hydrology model to figure out these combinations of land cover types and soils. This is in acres, but that then allows me to run my hydrology model, which might give me results like this. Now, I have to say, the hydrographs that we're looking at here are not for Wildcat Creek. It's for Campus Creek right here on our own campus. So the hydrograph you see on the left was generated using procedures we just went through, calculated in that TR55 model. And like I showed before, under current conditions, which is largely urban land cover types, with very low infiltration soils. We would typically see for a 10-year storm, peak stream flow in Campus Creek 10 hours after peak precipitation, about 900 cubic feet per second stream flow. On the right, we were kind of curious. Actually, students in the NRES secondary major did this analysis. We were kind of interested in the influence of land cover on the stream dynamics of Campus Creek. So what if we went in and made land cover not what it actually is, but what we would have expected it to be before in kind of prehistoric times, right? Basically just grassland and forest, a little bit of riparian forest. And you can see that the shape of the stream hydrograph changes a little bit. We still have peak stream flow at about 10 hours after the storm, but notice stream flow is half that of what it is currently. So again, we had a modeling exercise that we wanted to perform. This one was surface hydrology, but it needed data, spatial data that we've acquired and pre-processed inside the GIS, translated it into a form that we can use to parameterize the model. We run the model, we get our result. So kind of in a nutshell, that data science procedure from formulation of your question or identification of a task to acquiring data, pre-processing it, doing a little bit of analysis. Before we wrap up, just wanted to remind, especially students that are here today, if you want to go into more depth on any of the techniques that we've talked about, we offer here at K-State a pretty comprehensive curriculum in geographic information science, from basic visualization through AI and geocomputational methods and everything in between. Desktop GIS as well as server-side GIS. No undergraduates here today. We have a graduate certificate in GI science. That's a nice addition to any major field of study. If you want to learn more about GIS, part of our one of our benefits of working with Esri as our software partner is they also make available their web-based training modules free of charge to all K-State faculty, staff, and students. I've highlighted here just for your reference a learning plan, which if I were connecting live to that website, the Esri training site, would list several web-based courses under the category of GIS fundamentals. So if you want to learn a little bit more about ArcGIS Pro, or you're really into LiDAR, there are courses that will walk you through how to do different types of things with different pieces of their software system. Really, really useful.
We get a bunch of them for free, the online ones. We get a discount for the instructor-led ones?
Yeah, there's kind of two basic categories. The web-based, all should be free. Don't pay for any of those. That's right. You have to sign in using your linked K-State account. And yes, if there are really excellent instructor-based courses that are done generally in person at their regional offices across the country. Great courses. If that's something that you're interested in, you will have to pay, but we, because we're so cool at K-State, we get a discount on those.
Is K-State ever going to offer a certificate online?
Talk to the Dean of the College of Arts and Sciences and the Provost on that matter.
For those of us who work remotely and who
Yes, we would love to.
I love driving here, but I'm not going to do it every day.
Yes, I wish all of our stuff could be available online. We have one more workshop, Matt Monday's workshop here this semester. Yes, it is November 3rd. Rather than working on the desktop, we're going to be doing a little bit of desktop, but more ArcGIS online work in that session. And I'll also put out a quick plug. Next week, we have a session in the K-State Research and Extension Annual Conference on Wednesday at 1:30, I believe. if you want to see a little bit more, especially ArcGIS Online work. With that, I'll leave a link here or a QR code if you'd like to provide us with a little bit of feedback on the workshop. Say thanks for attending and answer any questions that you might have. Appreciate it.